Hello, my name is Bhola Gupta. I am from UP Kushinagar. In this class, we are going to discuss a very important chapter of class 10th, which is real number. This is the first chapter. Okay. Now, before starting this class, we must have to know about real numbers. What is real numbers? Okay. The definition of real numbers is real numbers are the collection of both rational and irrational. Okay, real numbers is nothing, it is a collection of rational number and irrational number. Okay, if you look here, this is the rational number and this is irrational number. Okay, the collection of both numbers are called real numbers. Okay, rational number, what is rational number? If I give the definition of rational number, the rational number is any number if we can write in the form of p by q. The condition is q naught is equal to 0 and p and q are integers. Okay, this is the simple definition of rational number. Any number if we can write in the form of p by q. Condition is q naught is equal to 0 and p and q are integer. Integers means 0 to plus infinity and 0 to minus infinity. Okay, if I give the some examples of rational number, the examples is 1 upon 2, 3 upon 4, minus 7 upon 6, minus 11 upon 13, 5, 0, minus 8, and dot dot dot, etc. These numbers are the examples of rational number. The next numbers is irrational number. Irrational number are the reciprocal of rational number. The definition of irrational number is what is irrational number? Irrational number is any number if we cannot write in the form of p by q. Okay, the examples of irrational number is those number which we cannot find the perfect square. Okay, for examples root 2. Okay, root 3, root 5, root 7, dot dot dot. The next example is pi, 2 pi, 3 pi, dot dot dot, and pi. Where n, what is n? N is a natural number. Where n is a natural number. Okay, natural numbers. Okay. So this collection of numbers, rational and irrational, this collection of numbers is called real numbers. Okay, got it my points? What I want to say, the collection of rational and irrational, these numbers are called real numbers. Okay, the next point of real numbers is real numbers can be represented on the numbers line. Okay, the real numbers can be represented on the numbers line 0, 1, 2. If you move here this side, -1, -2, -3. Okay, these numbers can be represented on this line, this number line. Okay, now let's move on next topic of this chapter. Now the first theorem from this chapter is fundamental theorem of arithmetic. What is this theorem? This theorem says every composite number can be written as a product of prime numbers in one and only one way. Okay, if you look here, the new word comes composite number. What is composite number? The definition of composite number is any number which has 3 or more than 3 factor is called composite number. Okay, for example 4. 4 is a composite number. Why? Because 4 has 3 factor. If I give the examples of composite numbers, the first example is 4 because 4 has 3 factor. 4 is divisible by which number? 1, 2 and by itself. Okay, if you look here 1, 2, 3, these are the factor of 4. Okay, so 4 is a composite number because 4 has 3 factor. The next example is 4, 6, 6, Next 8, 9, 10, 10, 12, 12, 14, 15, dot dot, and so on. These are the examples of composite numbers. Okay. The next numbers is prime numbers. What is prime number? Any number which has only two factor is called prime number. If I give the examples of prime number, the examples of prime number is first prime number is 2, because 2 has only two factor. 2 is divisible by 1 and by itself 2. Okay. Next 3, 5, 7, 11, 13, and so on. These are the examples of prime numbers. Okay. What is this theorem say? This theorem says every composite number can be written as the product of prime numbers. Okay. If you not understand this statements, give me 2 minutes. I will explain this statements by giving some simple examples. Let me give the examples of 12. 12 is a composite number, okay, because 12 is terminated by 1, 2, 3, 4, 6 and by itself. Okay, so 12 is a composite numbers. Okay, if I find the factor of 12 is terminated by 2, how many times? 6 times, and next again 2, 3 times, and next 3. Okay, 3 can be written as 2 into 2 into 3. Okay, or this form can be written as 12 is equal to 2, how many times? 2 times, 2 to the power 2 multiplied by 3. If you observe here, 12 is a composite number. 12 is a composite number. This composite number is equal to the 2 to the power 2 multiplied by 3, and you know that 2 and 3 is a prime numbers, and this symbol is a product. This composite number is equal to the product of prime numbers. This theorem say this. Okay, got it my points? This theorem say any composite number can be written as the product of prime numbers. Okay, let me give another example. The second example is 15. Okay, 15 is a composite number because 15 has 3 or more than 3 factor. Okay, 15 can be written as 3 multiplied by 5. Okay, if you not understand that, you can find in rough copy 15 is terminated by 3 how many times? 5 times, and again 5 1 times. Okay, so 15 can be written as 3 multiplied by 5, and you know 3 and 5 is a prime number, and this is the product, and this number is a composite number. This composite number is equal to the product of prime numbers. Therefore, any composite number can be written as the product of prime numbers. Okay. What is the use of this theorem in this chapter? The use of this theorem in this chapter is, with the help of this theorem we can find LCM and HCF. Okay, got it? Understand what I want to say? With the help of this theorem we can find LCM and HCF. Now, how can we find the LCM and HCF with the help of this theorem? Okay, let me give another example to explain how to find LCM and HCF with the help of this theorem. Suppose there is a two numbers. Okay, 12, and second example is 10. Okay, the prime factor of 12 is 2 times 2 and 1 times 3. So 12 can be written as 2 multiplied by 2 multiplied by 3, and 10 can be written as 2 multiplied by 5. Okay, now HCF, the meaning of HCF is highest common factor. Okay, if you look here, there is only 2 present in both prime factor of number. Therefore, 2 is the highest common factor of 12 and 10. Okay, now we have to find LCM. 2 into 2 into 3 into 5. 2 2s are 4, 4 2s are 4 3s are 12 5s are 16. 16 is the LCM of 12 and 10. Okay, this is the use of this theorem, fundamental theorem of arithmetic. Okay, now we can move in exercise 1.1. Okay, the first question of exercise 1.1 is express each numbers as a product of its prime factors. Okay, in the given problems we have to find only prime factors of the given numbers. The first question is 144 and we have to find the prime factor of 144, and 144 is terminated by 2. How many times? 70. Okay, again it is terminated by 2, 3 and 5. Now 35 is terminated by 5. How many times? 7 times, and 7 is terminated by 7 1 times. So 144 can be written as 2 into 2 into 5 into 5. Okay, if you look here, these numbers are the prime numbers and this is composite number. Okay, and in this question we have to find only prime factor of the given number. This is the prime factor of the given number. That's solved. Okay, the next number is, give me 1 second. The next number is 156. Okay, 156 is terminated by, first of all, 2. How many times? 7 and 8. Okay, again 2 3 times and 9, and then 3 13 and 13 1 times. Okay, now 156 can be written as 2 into 2 into 3 into 15. Okay, that's all. The next number is 3825. Okay, and we have to write prime factor of these numbers. Okay, 3825. It is terminated by which number? 8 or 10. Okay, this is terminated by 3. 3 is terminated by 3 1 times, 3 2 times, 6 2 carry, 7 21, 15 5 times. Okay, again it is terminated by 3 4 2 and 5. Okay, the next number is 425 is terminated by 5. Okay, 5 how many times? 8 and again 5. Okay, again 5 1 and 7 and then 70 1 times. So 3825 can be written as 3 into 3 into 5 into 17. Okay, this is the prime factor of the given numbers. Okay, and in this question we have to find only the prime factor of the given numbers. That's it. Okay, now let's move on question number 7.